So in this video, we're going to look at a fun recurrence relations problem, which is called the Hanoi Tower. The Hanoi Tower. So in the previous videos, you probably should have watched the introduction video to recurrence relations where we looked at simple examples. And those were just like examples to show what a recurrence relation is, but it wasn't like fun problems that require like you to find a recurrence relation and stuff. And in these kind of problems, we're in a scenario where a recurrence relation makes sense and is really elegant. Like solution, like recurrence relation solutions to really good problems are really elegant. So I hope you enjoy this video because this is a pretty famous recurrence relations problem. So yeah, to get the diagram up here, I drew all of this because I didn't want to. I was really bad at hand drawing this, so I kind of just drew this in advance. So if you don't know what this is, basically you have some number of plates differently sized, and the goal is to move all these plates from this pole to this pole, from the left pole to the middle pole. Ignore the middle pole, but we're gonna left pole to right pole, and ignore the middle pole. But yes, the middle pole will still be pretty important because, yeah. So we have end plates. Oh my god, yeah. So let's say we have end plates. So our goal is to move these from here to here. But of course there's a restriction because we can't just dump all of this here. So firstly, you can only move one plate at a time. And that's pretty simple to understand. But then also, you can't put a bigger plate on top of a smaller plate. So this kind of scenario. So this kind of scenario is illegal. Yeah. So given those restrictions, we want to find the minimum number of moves needed to move these from here to here. So that's our problem. We want to find the minimum number of moves needed to move these end plates from here to here, given those two restrictions. And let's say the minimum number of moves to move these end plates is given by an. So a minimum of an moves. So you want to find a formula for an. And it turns out that it's a recurrence relation. So a certain situation depends on the previous situations. So yeah, if you haven't played with this before, it'll be pretty. If you played with this before and you know how this works, then it's gonna be pretty easy for you to understand. But even if you don't get it, it'll still be pretty straightforward and really interesting. So before we dig into the general case, we're gonna look at some simpler cases like n equals 2. So for n equals 2, it's pretty simple. We just have two plates, one bigger and one smaller. And basically the structure of how we're going to do this is we're going to move the top part. We're going to move the top part out of the way so that we can move the base part to here, and then we're going to move the top part back on because we can only move one plate at a time. So we want to move the top part out of the way and to move the base part onto here. Oops. So yeah, so the only place to put this away is the middle pole. So we're going to move this here. And the base is still going to be here. And then we're going to move the base to the target zone. And we're going to have the top part here. And then we're going to move the top part back on top of the base plate. Oh. So yeah, there we go. And that is pretty easy to count because we just went step by step, move by move. So it took one move here, and took one move here, and then it took one move here again. So that's just a total of 3 moves. So in conclusion, we just get that A2 is equal to 3. So relatively simple because there's not many plates here. But what if we look at more plates? Then we're gonna need to find kind of like a summary of the moves. So let's look at n equals 3 because we want to see n equals 3 because we want to see how the scenario is determined by the previous scenario. So we're going to have our 3 plates. And we want to, so it's going to be the same structure as this. We want to move these 2 plates out of the way, the top 2 plates out of the way, so that we can move the base plates to the target zone, and then move the top plates back on. So we're not going to go move by move this time. We're not going to look at every single move. We're going to just look at a summary. So in the next stage, we want these top 2 plates to be out of the way, and the base plate will still be here. They look similar, but that's the base. And then we want to move this base to the target zone. So the top 2 plates are here. And then in summary, we want to move these. We want to have these 2 plates back on top of this base plate. So like that. And then, so in summary, this only took 1 move. Oops. This only took 1 move. And this, but here it's not, it didn't take 1 move. We were moving 2 plates from one pole to another. And how many moves would that take? Well, we already know how many moves that takes because that's just A2. Because A2 represents how many moves it takes to move 2 plates from one pole to another, and that's what we're doing here. So it's going to take A2 moves here. And same with here, we're moving 2 plates from one pole to another, so that'll just be A2 as well. So in conclusion, A3 is just 2 times A2 plus 1. So that's our formula for A3. And that's just equal to, because we found A2, that'll just be 7. So A3 is equal to 7. And then, now that we can see that a term depends on the previous scenario. So we're kind of getting an idea of how recurrence relations plays a role here. So now let's look at the general case, since we have a good idea now. The general case. So in the general case, we want to have, let's just go with, so for the diagram, we're just going to have 3 plates. Because I can't just, I don't want to waste time drawing too many plates. So, but in general is n plates. And the top, and we're going to look at the top n minus 1 plates, and then the base plate. We're going to look at it like that. So, in the next stage, similar to what we did here, we want the top n minus 1 plates out of the way onto the middle plate. So we want it like, I don't know, it shouldn't be red. So like that. Oh my god. Top n minus 1 plates are moved out of the way onto the middle pole. And then we want to move the base plate to the target zone. So like this. And then we want to move these n minus 1 plates back on top of this base plate. So in the next stage, we want these top n minus 1 plates back on top of the base plate. So to label it, n minus 1. So yeah, for this stage, it's pretty simple. It's just 1 move. But for this, we were moving n minus 1 plates from one pole to another. So that'll just take an minus 1 moves, because we're moving n minus 1 plates from one pole to another. And here, we're moving, again, we're doing the same thing. We're moving n minus 1 plates from one pole to another, so that'll just be an minus 1 as well. So in general, I'll write this in blue. In general, an is equal to 2 times an minus 1 plus 1. And there we go. We found the recurrence relation for the Hanoi Tower. So in general, to move minimum number of moves needed to move n plates, an, is equal to 2 times the minimum number of moves needed to move n minus 1 plates plus 1. So yeah, this is pretty interesting because it's like a real, yeah, it's like applying recurrence relations to a kind of like a real life scenario, and it looks pretty intuitive to use recurrence relations. Like the previous, we're kind of dividing this into sub problems to produce this recurrence relation. And yeah, again, to describe a recurrence relation, we want to add the base case, which is that a1 equals 1, which is pretty trivial to prove. So yeah, this is the Hanoi Tower, and so we found the recurrence relation for the problem. So yeah, this is how recurrence relations works, and this is one of the most famous problems for recurrence relations. And I may make some more videos on more interesting problems, but in another video we're gonna look at some more complex recurrence relations and how to deduce that from the problem. So yeah, hope you enjoyed this video, and see you in the other recurrence relations videos.